Today's lesson is going to be on the law of sines. And one of the things you're going to deal with quite a bit as an engineer or in your engineering courses are vector quantities, or quantities that have a magnitude and a direction. You could be looking at machine elements that are in rotating equipment, or you could be taking a look at a tower, like the example problem here. But the law of sines and our other trigonometric relationships and identities are going to help us out with solving for these problems. So we'll take a look at one of the tools you have here, which is the law of sines. And you can see our triangle drawn up here, that you have the angles are indicated by capital letters, and you've got the side length opposite those angles by the same letter but the lowercase. So here you have the sine of the angle A over length A is equal to the sine of B over the length B is equal to the sine of angle C over length C. Now, likewise, you can certainly take that and just flip it if that makes your life easier, and you can write it as is indicated right there below. A over sine A is equal to B over sine B, and so on. So the exact same relationship. It just depends on which one you want to work with, what's going to make your life a little bit easier. You may find that if you're trying to solve for an angle, maybe you want to use the first one. If you want to solve for a length, you use the second one. In the end, it doesn't matter. You're going to get the same answer. Well, one of the things we should address is that there are times that you could have an ambiguous case. It's a unique situation where you have an acute angle that's not in between two known side lengths. So here I have angle A, for example, and I've got the side lengths A and B are known. In this particular case, since I don't know the other angles, it's possible up here that angle B is going to be the smaller one, or it's going to be this larger one indicated in red. So you'll see those two possible unknown side lengths there are going to have a different angle there. So you're going to end up with a different triangle, two possible solutions with the information that you're given. Pretty unique situation when you have the acute angle. You've got these three pieces of information known and no other information about the sides and angles. And in this particular case, you have A is less than the length of B. So those you could end up with that. In that case, it's pretty easy to deal with, actually. All you have to do is take a look at it and realize that you could end up with an angle B. Solve for here, the B in green, or you could have 180 minus B is equal to B prime. Okay, so you have those two possible solutions. Take the one that makes sense to the situation that you have. You really have to take a look at the problem that you have and your individual circumstances. So now let's take a look at our example here. And here what we're trying to find is we want to find the height of this tower. Now we can't measure it directly in this problem, or we weren't able to. So we want to determine, and what we do know is we're able to measure these measurements. So we know this, the tower is leaning 8 degrees from the vertical, and we know that an observer, here's our observer here, is sighting up, and he sees that this is a 30-degree angle to the top of the tower. So we have these three pieces of information, two angles, right? One which we have to actually determine here, but we have the information we need, and we have one length, and we want to find this height. So let's call this little a, and this is going to be little b. Okay, so we're going to go ahead and use the law of sines to solve this problem. And we know that little a is unknown. A is 30, so this is a over sine 30 is equal to b, which we do know, over sine of b. Well, we need to know what b is. This is pretty easy to determine, but we don't know it quite yet. So, what we do know is that here, this is 8 degrees, and this is a right angle. So this angle in here, this angle C, is actually going to be equal to 90 minus 8 degrees, because it's that portion of the right angle. So this is going to come out to be 82 degrees. And then we know that now that angle B is going to be equal to 180 minus 82 minus 30, because we know that this whole triangle has 180 degrees in it. So now we're going to work with our algebra here and see that we get 100 times sine 30 over sine, and this math turns out to be 68 degrees. Okay. We plug this into our calculator, pretty straightforward process, and this is going to come out to be 54 meters. So the height of our tower is going to be 54 meters. Now, we can also work this the other direction, so let's go ahead and do that. And so now we want to take a look at our problem here at number 2, and we're going to take two forces. Force 1 here of unknown length and magnitude, and this is going to be a 100 Newton force, and we know that the angle in between these is 120 degrees. And we've taken a measurement, and we know that when we sum those two forces together, that we end up with a resultant force of 132 newtons. And what we want to determine is what is the angle here that that resultant force is acting at. So we have these two forces acting on the same object, and we want to know the angle of the resultant force here. So we can go ahead and set this up, and now let's use the opposite one and say that the sine of A over A is equal to sine of B over B. Okay, so we can go ahead and say that we're trying to solve for this angle. Let's call it A. So we have the sine of A over 100 newtons, that's opposite that, is equal to the sine of B, which is 120 degrees, over 132 newtons. So sine A is going to come out to 100 times sine 120 over 132. Okay, now, in the end, what we're going to come up with here is that the sine of A is equal to about 0.656. Since we know this number that the sine is equal to, we can take the arc sine of that in our calculator. And now A is going to be equal to the arc sine of 0.656, which is going to come out to about 41 degrees. Okay, so you see an example going in each direction. So you understand that there is this ambiguous case that's a possibility in some circumstances. Now we're going to give you a homework problem so you can take a look at this and work through it yourself, looking at some of the components of a machine, some machine elements, and looking at their positions and determining the unknown. So we'll put that up and give you an opportunity to write it down and solve it.